Alright, in this video we're going to do two more examples of the chain rule. And again, to remind yourself, the chain rule takes the derivative of a composed function where you multiply by the derivative of the outside function with respect to the inside and multiply that by the derivative of the inside function. And again, you can use the chain rule multiple times, doesn't matter how many functions are nested in there, you're going to have to use the chain rule. So I have two examples. I have x times the square root of 2x plus 1 and the cotangent of 2 over t. And we're going to find the derivative of both of these. So first we're going to do the first one, x times the square root of 2x plus 1. And to start, I would rewrite that as x times 2x plus 1 raised to the 1/2. So it looks like we're going to have to use the product rule in conjunction with the chain rule. So y prime is going to be, well, let me take the derivative of this first and multiply that by x. So the derivative of this, we take the 1/2 and pull it out front by the power rule. So it's going to be 1/2 times 2x plus 1. That's the derivative of the outside function with respect to the inside. And then again with the power rule, we have to subtract 1 from this power. So it's going to be to the minus 1/2. So that's the first part of the chain rule. We multiplied by the derivative of the outside, which is something to a power. Then we multiply by the derivative of the inside. And the derivative of the inside, 2x plus 1, is just simply going to be 2. And then we multiply that by x. And then we do the product rule here. I did the derivative of the second times the first. Now I need the derivative of the first times the second. And the derivative of x is just 1. So I'm just going to rewrite this again. So it's just 1 times 2x plus 1 to the 1/2. And now we can start simplifying. So, let's see. Well, this is going to be 2 times 1/2, and that's just 1. And this is just going to be in the denominator, so that's going to be 1 over the square root of 2x plus 1. And to that I'm going to add the square root of 2x plus 1. And that's the derivative. And again, you can probably rationalize the denominator or combine fractions with common denominators, but I would just leave it like this. And now we have our second one. S is equal to the cotangent of 2 over t. Well, we're going to have to use the chain rule on this one. And we could use the quotient rule, but I'm going to rewrite this as the cotangent of t, well, 2t to the minus 1. And it's much more simpler to see that we can use the power rule. So the derivative of s with respect to t is going to be, well, let's take the derivative of the outside function with respect to the inside. So the derivative of cotangent, let me do it off here. The derivative of the cotangent, we can say cosine of x over sine x. And we apply the quotient rule here. So it's going to be bottom times the derivative of the top, which is minus sine x times sine x, minus top times the derivative of the bottom. That's just going to be, I'll write cosine squared. It's going to be over the bottom squared. Well, we have a minus 1. Well, excuse me, we have a minus sine squared. So I'll just pull the negative out front. Minus sine squared x plus cosine squared x. And that's going to be over the sine squared x. And, well, that's just going to be, this is just 1. It's going to be minus 1 over sine squared. And let me erase this part of this line. Okay, sine squared x, and that's just minus cosecant squared x. So that's the derivative. So we say minus cosecant squared of 2 over t. Then we multiply that by the derivative of the inside. And if we just use the power rule, bring this power out to the front. That's going to be minus 2. And that's just going to become t to the minus 2. So that t is going to come down in the denominator like that. And lo and behold, that's our derivative. So here we've used the chain rule and power rule, and then on this one we have to use the product rule and the chain rule.